Hello, welcome guys. Today we are going to solve a question based on work energy theorem, and there are two parts in this video. In first part, I will try to explain which type of difficulties we will face when we are going to solve such type of question with the help of fundamental equation F is equal to ma, and in next part we will solve this question with the help of work energy theorem, and you will see we will wonder how work energy theorem make such type of question super easy. Okay guys, so let me write down the question. The question is a block of mass 2 kg. Let me write down a block, just make a capital, a block of mass 2 kg, of mass 2 kg is, okay, it's not right, 2 kg is initially at x is equal to 2 meter, and a force of F is equal to minus 2 xi act on it. Okay, here x is in meter. Okay, fine. Kinetic energy at x is equal to 2 meter. Okay, and second, what is the maximum kinetic energy? What is the I will solve such type of question next. Find maximum kinetic energy. Okay, first we will solve this question. Okay, so we are going to solve the question. Okay, guys, if you see this question first time, when you are beginner, then the first thought which come in your mind is kinetic, and we that the kinetic energy is basically half mv square. Okay, and the first thought which come in your mind that the mass is 2 kg, so you have to just how calculate, anyhow you have to calculate velocity. If you know the velocity, then you know the v square, and then you are able to find the kinetic energy. Okay, so the first approach which come in your mind to find kinetic energy is find F is equal to ma, and you think that if you find acceleration, then with the help of this acceleration you will find velocity. Okay, so if we apply this equation, so what we get, F is equal to 2 minus 2x, this is equal to 2 into acceleration. So here acceleration is basically minus xi. Okay, here acceleration is basically minus xi. Okay guys, and when you see such type of question, the first thing, and what can you write, acceleration is equal to dv by dt is equal to minus xi. Okay guys, now here here this is this and after that you are trying to integrate it, something like this. Okay, you will try to integrate it. Guys, here the f is not constant. Here x, this x, sorry, forgive me, this is not f. Here x is not constant. So you are not able to integrate this equation. Okay, you after doing this such a step easily, we just stuck here. Okay, you just stuck here. So and you have no idea what to do after it. Okay, and the second, and the some of the student can, what can they do, that they do, you know write it in this manner. They will write dx dv by dt is equal to d2x dt2. Okay, and they will write this manner, minus x. Guys, again here you are stuck to solve this such type of differential equation. Okay, because this is the differentiation. So you are not able to solve, you have no idea, you have no clue how to solve such type of equation. Okay, so you will stuck here. So to okay, guys, this is not a difficult equation, but at your level it is quite difficult, because you have not studied, you have not learned how to solve such type of differential equation. Okay, so you will stuck here. Okay, so if you try to solve such type of question, then you face a problem. Okay, and okay, so now, yeah, here you will face the problem. Now we are going to see how the work energy theorem make this question super easy. Okay, so let me write down here. What is the work energy theorem? Basically work energy theorem is, here I will calculate. Here I am going to write down work energy theorem is basically the change in kinetic energy ke2, change in kinetic energy means kinetic energy final minus kinetic energy initial, is equal to work done. And what is the work done? Basically F dot ds. Okay guys, F dot ds. And what is the ds here? Ds here is dxi dyj plus dzk. Okay guys, in first look such type of writing, such type of things look stupid, but this is the way we'll try to solve a simple question. We'll first make a simple question difficult, and then if we faced a difficult question, then we are able to solve such difficult question very easily. Okay, so if you wanted to learn the concept, you have to make a simple question difficult. Okay, so due to this reason, I always like to write ds in this manner. Okay, so here the ds is equal to basically dxi dyz dzk. Guys, here the motion taking place only along x-axis. Okay, so these two guys, dx dyi dyj and dzk, is going to be 0. So here basically ds is finally dxi. Okay, dxi. So so changing kinetic energy is basically these things. Okay, so what is the what is the initial kinetic energy? What is the what is the initial position? Initial position is at x is equal to 2 meter. At initial position x is equal to 2 meter. So what is the initial position? Initial position is 2. And what is the velocity? Oh ho 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 ho. Okay, at initial, here I forgive, pardon me, actually at x is equal to 2 and it is in rest. Okay, in rest, initially is in rest. Okay, yeah, rest is correct, to make this question simple. Okay, otherwise you will face in the calculation. We are not interested in doing calculation. Okay, so it is in rest at x, initially at x is equal to 2 meter, and it is in rest. Okay, so here what is the kinetic energy? Initial kinetic energy, half into mv square, half m into 0. So what is the initial kinetic energy? This will be the 0. And what is the final? Half mv square. We don't know what is the final. Okay, so so what is the work done? The change in kinetic energy basically F dot ds. Okay, so let me write down ke2 minus 0. This should be equal to f. What is the f? Minus 2xi. And what is the ds dot ds, which is basically dxi here in this case. Okay, so what you get here, ke2, this become here how to take dot product, you should know it. Okay, I'm not going to explain how to take dot product. I just write down minus 2 x dx. Okay guys, you should know why I take this 2 out of this integration box. Okay, so ke2 is equal to basically minus 2x square d by 2. Okay, now guys we have to put limit, okay, here. So what is the initial position? Okay, let me draw the diagram, diagram of motion. Here this is the origin. Let's suppose this is the origin O, and initially the object is at x is equal to 2. So object is at x is equal to 2. This is x is equal to 2, and finally it is here. So guys, this initial position is x is equal to 2, and final position x is equal to 0. So here 0, 2 to 0. Okay, 2 to 0. So if you look at this, what it become, 2 to cancel out, what we find, 0 minus 4. 2 square is 4. So what is the kinetic energy? Final kinetic energy 4 minus 4 into minus 1, that will 4. Okay, so what is the final kinetic energy is equal to 4 joule. Okay guys, so hope you will like this video. Thank you, thanks for watching.